Alright, in this tutorial, we're going to be solving a problem that's actually related to the density and the specific gravity. So this problem reads the length, height, and the width of a rectangular cube looking shape are 1.02 yards, 10.5 centimeters, and 4.5 feet, respectively. Calculate the mass of the object in kilograms if the specific gravity is 4.53. Okay, well, we're given the specific gravity here. So specific gravity is going to be 4.53. And if you guys recall, the specific gravity is measured in the form of density of the object. So in this case, whatever that rectangular cube is, I'm just going to write that down as an object here, divided by the density of the water. So specific gravity being 4.53, and the density of object is what we're trying to figure out, and the density of water, we can take that as 1.0 grams per milliliters, or even grams per centimeters cubed. So let's take that one to make it a little bit easier. And even if you take its milliliters, remember 1 centimeters cubed is equal to 1 milliliters. So at the end of the day, the density of the object comes out to be, when you do this math here, it's not really going to change anything other than just keeping this 4.53 grams over centimeters cubed. So remember, the density of the object and the specific gravity of the object is actually the same, but specific gravity doesn't really have any units. Okay, so now the question is asking to find the mass of the object, and remember the density of this object is going to be equal to the mass divided by the volume. That's the definition of density. So we know the density, we don't know the volume. So if we are, however, given the dimension, so if somehow we can figure out what the volume going to be, we can easily figure out the mass. Okay, so the volume here we want to figure out in centimeters cubed. So since it's in a rectangular cube, the volume is going to be the length times the height times the width, and the units we want to have should be centimeters cubed. Now, why centimeters cubed? That's because the density of the object that we just calculated or retrieved from the specific gravity has the centimeters cubed in there. So that's why you want to make sure the units are same in both cases. However, the length is given. So length is 1.02 yards. Then we have the height to be given 10.5 centimeters. And then we are given the width to be 4.5 feet. Well, we already have the height in the centimeters, so we don't have to worry about converting that. However, the length, which is given in yards, and the width, which is given in feet, we need to convert those into the centimeters. So let's do the dimension analysis on those. So starting out with the length here, if I want to convert the yards, I'm going to write down that here. So if the yards can be converted to the feet, okay, and then the feet can be converted to the inches, and then the inches can be converted to the centimeters. So that's one way of looking at it. So how many feet are there in 1 yard? So make sure you know the conversion factors there. 1 yard is 3 feet. And then how many inches are there in 1 foot? 1 foot is going to be 12 inches. And then how many centimeters are there in 1 inch? 1 inch is going to have 2.54 centimeters. So make sure you know the conversion factors here before you actually start converting them. So now I know how I'm going to convert the yards to the centimeters. So let me just go and write that out here. So starting out with 1.02 yards, So in the first step, the yards will be converted to the feet according to the plan. So I'll have the feet on the top and yards needs to go on the bottom so that the units can cancel out. And you know 1 yard, 1 is going to go with the yard because that's what we have in the equality there. And 3 is going to go with the feet. So yards cancels out here. And then in the second step, the feet needs to be converted to the inches. So I'll have inches here. And the foot needs to be on the denominator. So keep in mind whatever unit you're trying to find out goes in the numerator, and whatever units you're trying to get rid of goes in the denominator when you're writing your conversion factors. So the feet cancels out here, and you know 1 foot is going to be 12 inches. And then finally, I want to convert the inches to the centimeters, so I'll have inches in the denominator and centimeters on the top. So I would do 1 inch here and 2.54 centimeters there, because remember 1 inch is 2.54 centimeters. Doing so, inches goes away, and that will give you the final answer there. So we got 1.02 times 3 times 12 times 2.54. So that's going to be the length in the centimeters, not necessarily the final answer yet. So 93.269 is the length in centimeters. We want to do the same thing for the width now. So width, we have the feet. So going from the feet, we want to go to the inches and then to the centimeters. So we already have those conversion factors laid out. So let me just go and write that down. So we got 4.5 feet. And then in the first step, I will convert the feet into inches, just like what we have done in the previous question, in the previous setup. And your foot will cancel out by putting them in the denominator. So then remember, 1 foot is 3 inches, rather 12 inches. And then the inches needs to be converted to the centimeters. So centimeters goes on the top and inches goes on the bottom. And you know 1 inch is going to be 2.54 centimeters. When you place the units accordingly, your feet will cancel out, inches cancels out, and that leaves you with the centimeters there. And that's the unit you're really looking for. So I got 4.5 times 12 times 2.54, and that gives you 137.16 centimeters. Okay, so now we got all 3 dimensions of these cubes in the centimeters. So all we really got to do is just go and find the volume now. So your volume is going to be length, which is 93.269 centimeters, times the width, which is 137.16 centimeters, times the height. And the height was already given in centimeters. That was 10.5 centimeters. So we'll go ahead and put that down here. Okay, so what that comes out to be, let's say 93.269 times 137.16 times 10.5. So it gives you 134,332.7 centimeters cubed. Okay, so we know the volume now, and we already know the density. So the density, if we go back here, the density was 4.53. So it's going to be 4.53 grams over centimeters cubed as your density, and that's going to be equal to the mass divided by the volume, which we just calculated to be 134,322.7 centimeters cubed. So here I can multiply both sides by this 134,322.7 0.7 centimeters cubed. And when you do multiply both sides by that, you will get mass equals to 134 322.7 centimeters cubed times 4.53 grams over centimeters cubed. So when you do set it up like that, your units cancels out, and all you really got to do now is just multiply the volume with the density there. So 134,322 times 4.53 is going to give you 608,481.8 grams as the mass for this object. The question is asking to calculate this mass into the kilograms. So make sure you do use this last setup here where we have 608,481.8 grams. And then we want to go ahead and convert it to the kilograms, and we want to get rid of the grams. And what's the conversion factor between the kilograms and the grams? Well, kilo is just a prefix, which is 1,000. So that means it's going to be 1 kilogram equals to 1,000. So 1,000 goes with the grams. By doing so, grams cancels out, and that leaves you the answer in kilograms only. So this, when you divide that, it's going to be 608.481 kilograms as your final answer. And then you can go back and check how many sig figs you really need to keep. So if I go all the way back here, the lowest number of sig figs, so 1.02 has 3 sig figs. 10.5 also have 3 sig figs. This 4.5 actually has 2 sig figs. And then this 4.53 also have 3 sig figs. So since all you're really doing here is just multiplying and dividing, your final answer should not have more than 2 sig figs. So when you go back down here, how much it's going to be with 2 sig figs? Well, 608 will become 610 kilograms in 2 sig figs. That's one way of writing it. You can also write it in the scientific notations as 6.1 times 10 to the 2 kilograms. So either one of those ways are fine. So your final answer is 610 kilograms. All right, so if you have any questions, feel free to leave any comments in the section below.